Hi, everyone. Welcome to SingleStore's ChatGPT Dev Day live from AWS Atlanta. My name is Alina, and I'll be your moderator today. Before we kick things off, I wanted to go over a couple of housekeeping items. Please note that this is a hybrid event with both on-site attendees here in the classroom, as well as many folks joining us virtually from all around the world here in our Zoom session. However, if you are in the classroom with us right now and you haven't done so, please get out your laptops now, click the Zoom link in the calendar invite and join the session. There's a few workshop tutorials during the session that would be just a little easier to follow along with, and a couple of links that we'll be sharing in the chat. So please just keep your volumes off since you'll be able to hear our speakers just fine here in the room, and we don't have an echo for the people on the Zoom. Plus, there's going to be an Apple AirPods raffle coming up. If we can go to the next slide, Gabe. One more. Yeah, here we go. So yeah, we'd love for you to try today's technology firsthand. So anyone who tries it today will be entered for a chance to win a pair of branded AirPods Pro. Simply click this link in the slide or scan the QR code and log into SingleStore. Either you create a new account through the trial or you just log into your existing account if you have one. And we'll be checking the folks who have logged in, and we'll be announcing a winner by the end of today's session. Next slide. So for the audience in the room, feel free to raise your hand if you have any questions. And for the virtual audience, please post your questions to the Zoom Q&A, which we'll be moderating throughout the session, and make sure that we answer all of your questions. And one more thing, if we go to the next slide. We will be having a SingleStore sponsored happy hour for anyone who is in the Atlanta area. So if you're not in the classroom with us right now, but you still like to join, you're welcome to come by the Industry Tavern at 6 p.m. So feel free to take a quick screenshot of the slide or copy the address, and hopefully we'll see you there. And if this is your first time joining a SingleStore webinar, just a heads up that we present weekly technical workshops demoing data and AI use cases and new technology. So you can find all of the information on our website. And I will also post a link in the chat here. And that's all I wanted to share. So I think we can get started with the main session. So let me introduce our speakers for today. First up, we have Melissa Bader. She's a solutions manager here at AWS in Atlanta and has worked for 20 years in software and engineering roles at Cisco, Google, and many, many others. Sarang Tripathi is the global head of pre-sales at SingleStore, and he is based here in Atlanta as well. Sarang has a decade of experience in designing real-time applications, including roles at IBM and TIBCO. And Gabe Kafidi is the principal solutions engineer at SingleStore. He's based in DC. And before SingleStore, Gabe worked in solutions engineering roles at multiple companies, including NetApp and others. Welcome, everyone. Melissa, you're first up, so I'll pass it over to you.
Yeah, sorry about that.
All right. And so, it's just amazing the creativity that this has unleashed. And it's interesting just how quickly it's happened. Do any of you feel like all you've been thinking about the last 3 months is GenAI and you can't learn it or do enough and be up to speed? That's how my inbox went from 1 week, there was nothing. Then all of a sudden it's mandatory training. You're getting, so we're all trying to kind of figure out what our next steps are in this. Come on. Maybe your laptop is not liking me. Again, Gen AI is like, it's just evolutionary from what has been happening in machine learning overall. And really, when we think about it, we've been able to do a lot of these things already. It's just now we're able to augment them, to expand and innovate much faster. And so essentially a foundational model we know is pre-trained on vast amounts of unstructured data. The number of parameters has just been increasing exponentially into trillions of parameters can be in these models, whereas a few years ago we were at thousands of parameters, and we thought that that was really like huge and awesome. And then there's a wide range of contexts that we can use them for, and it doesn't have to be a very specific type of model. Now we can just take one of these ginormous models and apply it to many situations. And the exciting thing is that you can customize these foundational models with very little data, very little computational power on your point, and then specialize it for whatever your business use cases are. So again, as we kind of said before, we had to have specific models for each of these tasks, whether it be text generation, summarization, information extraction, Q&A, chatbots. And you guys probably know, as data scientists and developers, you had to take that data, you had to clean that data, you had to identify, the data sets, and then you'd feed it into your model and train it, and then you'd have to deploy it, and it would have the specific task that you wanted to accomplish with your model. Versus what's so exciting now is that we can take these ginormous, data sets into these foundational models in this pre-trained environment and pass it through the model, and it can do any and all of these things exceptionally well, as we're finding. So again, we really don't need to do a whole lot on this, but we're seeing a text-to-text. And we've all been playing around with that, where we can, do summarization and things like that. Text to embeddings, a great example of this. That you go to Amazon, which hopefully you all love and do all on a daily basis. If you were searching for hand soap, if you're this, how do we take that and then actually return back all of those images and those products that you might be interested in, and how do we do recommendations? That's a great example of text to embeddings LLMs. And then multimodal, when you can go ahead and give an NLP type input in there, and we want to have you create something for it, and then it takes what yours is and then returns an image customized to it. Is one example of the multimodal. So right now, Goldman Sachs did a study, and they're estimating that it's going to generate about $7 trillion in new business over the next 10 years. And I think that's why we're all here, is how do we, leverage Gen AI to help create that value for our companies and our lives. So, obviously we have new experiences that this is enabling. If any of you have kids, I hate to say this, they're very much aware of this, and now their new experiences. This is how I'm going to do my homework now. Just be very aware. Productivity, implementing some of these Gen AI tools, code generation, et cetera. We're seeing productivity increase for developers, by as much as 57%. So incredible productivity, being able to take and synthesize your business data, to do this, to extract the insights to enable faster and better decision making, and then obviously creativity. Before, if you were tasked with doing a blog post or creating these things, a lot of us wouldn't even know where to start. And now small businesses and others are able to leverage this technology and really enable themselves to, to scale and succeed in the marketplace today. So some of the wide variety of use cases that we're seeing here, if any of us have noticed like personalization, if you guys only need to go into like a Home Depot and have a conversation, have you noticed that the ads immediately start and follow you around? And that's, again, you may think it's a little creepy, and you may like it because now you're getting a lot of information. But even in contact center analytics, I've had a client that like was really looking at, the human to human interaction, and like, could we get more predictive about a more efficient customer experience in our contact centers? How could we, do sentiment analysis in order to resolve issues faster? Agent assist, chatbots, boost employee productivity. Again, if you guys are using this, how can we help our employees find information faster that's more relevant to them? Content localization, if that can handle that automatically for you, and improve our business operations. And this is a big part right here that we're doing, document AI for, processing all of that text and unstructured data, synthetic data creation. How can we do anomaly detection? That's been a big use case for a long time. And then obviously the creativity aspects as well. So I think we got a little bit of a bum rap at first, that we weren't really serious about AI and ML because, like ChatGPT came out, and, Microsoft had heavily invested in OpenAI. And it was kind of like, well, what is the AWS story? And so this is where I just want to kind of say that this is actually in our DNA. We've been doing this for over 20 years. And so when you guys really think about what Amazon does and how we do it, obviously there has to be a huge amount of machine learning and AI that's happening. So, and this is probably outdated. And if it's Prime Day, double these numbers, over 4,000 products per minute sold on Amazon.com. And how do we do all of the supply chain and forecasting? This is all being done. It has been done for some time with AI and ML. Our data centers, or excuse me, our distribution centers. I've been in the data center world way too long. Our distribution centers, how do they optimize that? Have you guys ever really thought about it? The fastest time to order that we've done, from the time you ordered, Amazon was able to deliver that in 26 minutes is our fastest. Like, guys, come on, like it's absolutely amazing. Alexa uses over 30 different ML models and helps, consumers with billions of interactions on a daily basis, whether it's be ordering things, getting you recommendation, giving you those wonderful notifications. I love my Alexa. I didn't even know it could do some of the things it could do, like reservations and suggesting restaurants. And you guys just really need to like get to know Alexa better. And then I was just out in Seattle. And so obviously, AWS's hub, and they had the whole Palm to go that you could do. So now, not only do we have, with our drones doing delivery, but we have literally, you have the capability, the Amazon to, retail to go, and you can just pick things off the shelf. You have your account, and it just, you don't even check out. You just take the products and it charges your account. But now you can just scan your Palm, and it literally will use that for your, checkout stuff. So super cool stuff we've been doing at Amazon for some time. And more than 100,000 customers use AWS for ML. So, and they're of all sizes, they're of all industries, but we are definitely their answer for this. And so I presume you guys are coming from several different, industry verticals, and maybe you guys have ways that you're already using GenAI or thinking about using GenAI. But one of the things I want to say, just because not only is my role, solution architect, but it's also strategic and, business focused. The most important thing is, what is going to be your use case? How, if you're going to make this investment, what is it that's going to monetize it and provide a return on your investment? And we'll kind of get into some of the costs in a bit on this. So unlocking the potential for GenAI, how do we do this? Obviously, it's transformative. It has tremendous business value that we think that it is literally going to transform all customer interactions in this. But there's also some blockers to this. Like, it's not necessarily easy to know, how to build these foundational models, which ones to use, how to customize it. What is the most price performant infrastructure? If you guys haven't run into it, there's a global GPU shortage. NVIDIA is made some assumptions when we were all kind of the doom and gloom, and then the crypto crash. And so, there's a capacity constraint that's out there. So again, this is not cheap infrastructure. So how do you get the most price performant? And then, our Gen AI powered applications. Like, what are those? How can that use to accelerate your journey? And then having flexibility. And we'll focus on that when we get into, oh, it still doesn't like it. Okay, which is Bedrock. Have all of you heard of Amazon Bedrock? Okay. Is anybody here in the preview program for Bedrock? Awesome. Okay, so if you haven't, so Bedrock is our managed AI offering that literally will eliminate the need for any infrastructure on your part. All of that will be managed by the scene. And what they do is it gives you access to a variety of foundational models. And people have like, well, ChatGPT, well, that's one. And they have like ChatGPT 3, which is public. And then if you want to get to their premium tier, their larger GPT-4, that's going to sign up and cost you. But through Bedrock, we're really providing you API access to a variety of foundational models. So it gives you choice and flexibility. No need to manage infrastructure. You can have from, AI 21 Labs, Anthropic, Stability AI, plus the Amazon offerings as well. And you can customize it and keep your customized version of your foundation model with, securely within your AWS account, and it never leaves that. And again, the model would be trained on your custom data, not on the foundational model. So we can look at that a little bit more. So again, we have our Titan FMs. We'll look at that a little bit. Jurassic 2, we have Claude 2, Stability Diffusion. And you guys hopefully are familiar with some of their capabilities, but I won't go into these too much. But I'll maybe you're not as familiar with the Titan base. Currently built with 20+ years of our experience and what we've learned from implementing machine learning. Obviously, we can automate, text summarization, text generation with our text version of it, and we also have Titan's embeddings. Then also we support responsible use of AI by having some built-in controls on user input, what we're going to display, removing, hateful or, violent speech and stuff, so that it's already, built in that we're trying to, be a leader in the responsible AI use case. So that's built into the Titan models. And we're starting with these two, and there's going to be more. And that's all I'm going to say. But secure customization to drive differentiation. So again, you can again, within your AWS infrastructure, you could point it securely within your VPC to your S3 buckets with as little as 20 different examples. You can privately train that model. It doesn't take very much. And so what you've done right there is with a very little bit of connectivity in order to fine tune that, then again, you have your own version of that FM, and it will, customize it for your specific use case. And I'm really going through these slides really quickly. And also what's really awesome about being in the AWS infrastructure is that it makes it so easy to, to take it from either Bedrock and deploy those models, and then also to integrate it into all of your other AWS kind of, control and governance procedures. So again, it's tools that you can use. We're going to talk a little bit more about SageMaker and the capabilities that it brings to the table. So just some use cases here with Coda. And they were able to quickly incorporate GenAI with all security and privacy. And they have tens of thousands of teams running on Coda. It's rolling at Uber, New York Times, and Square. So again, they went ahead with our infrastructure and was able to quickly bring GenAI into their model. So most price performant infrastructure, I mentioned about GPUs being constrained. And so hopefully you guys have heard, we've introduced 3 different, specific chips that we are very happy about. Our Inferentia, again, up to 70% lower cost per inference than comparable EC2 instances. So we have our Inferentia, which is specialized for deep learning models. Our Trainium, as what you guys can imagine, is for training your models, and up to 50% savings on training costs over comparable EC2 instances. And our Inferential 2, 40% better performance, because cost is going to be a factor in this. This is something I know you guys know. But in spite of us developing our own, we're always in this kind of cooperation kind of thing. We also have a very strong partnership with NVIDIA. And so our P5 instances were just recently made available. They are in our US West 2 region. And I will not go into all of the technical specs like I had planned to originally, but up to 6 times faster and 40% cost to train savings than previous GPU-based instances. I did want to go into cost on this just a tiny bit. I do have another customer that has actually been using P5 instances, and they, long story, they had a little bit of a glitch in their AMI and their network fabric adapters. And so they were kind of sitting there idling. And so the P5 instances, I just want to let you know, run at about $7,000 per day. So when you're looking at these number of instances that you may need, and at this, this is where literally you're getting this massive compute. But again, you're going to want to go into something that is going to be like very fully utilized, and that you're not having this capacity and this, this kind of cost associated if you're not sure you're going to be using, the full capabilities. So a little bit less, on the price threshold here is our P4D instances. Again, we have great use case, and these are the NVIDIA A100 GPUs versus the H100s, up to 2.5 times faster and up to 60% lower training costs on that family of the NVIDIA chips. And then we have, again, the A10G on our G5 instances, which is, again, a great option, and up to 3.3 times higher performance than our previous instances. A use case here, Finch used our Inferentia, and essentially by moving to Inferentia, they had an 80% reduction in cost, expanded support very easily to 3 additional languages, and accelerated their time to market. Runway is a content creation provider. And again, moving to the Inferentia 2, they had a 2 times greater, higher throughput, better experience for their customers, and they're able to create these incredibly rich, images and content and videos for Runway. So Code Whisperer, if you haven't heard of it, is I want to say that right now it is free for you guys to use. So you don't even need an AWS account. If you have an email, you can sign up and you can immediately start using Code Whisperer. So right over here, a preview productivity challenge, they were 27% more likely to complete tasks, and average 57% faster than trying to write code without Code Whisperer. Prior to AWS, I did work for Microsoft as well, and I was the TPM for everything that competes. And they did have a version of this as well. But again, these kind of tools are just absolutely invaluable for you on this. And if you're in AWS and using this, the integration again of this is pretty powerful. Again, things like scanning, code for hard to find vulnerabilities, generating code for you, literally writing as tab, 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 and flag code. So a lot of security built in. So at Accenture, they reduced their development efforts like literally by 30%. And if you guys can imagine, if your developers had 30% more time available to handle those, urgent requests, it would be wonderful. So we mentioned, I get this a lot. So flexibility. So we have our Bedrock, which is a managed AI platform that literally, abstracts all the infrastructure and does it. We also have SageMaker, which we'll go into. So again, you can go into SageMaker, and if you guys heard of SageMaker Jumpstart, it's definitely where literally you'll be able to go in. We provide not only those like access to the foundational, but a bunch of proprietary other models, a complete list I'll show it in a minute. but essentially you get to choose your model. It'll show you the instance types that it's going to use. So again, you have full control of your model training with the most price performant infrastructure because it's optimizing that for you. You can do distributed training over 40% faster with SageMaker. You have debugging and experimentation tools in there. And again, price performance inference. We got to get into ML ops and how do you deploy these models and scale them. It's going to help our governance built in, security controls, et cetera. And then we have human in the loop support as well. So it won't be just a machine we're talking to. So I mentioned about some of these. So again, take a look at, and this is constantly changing, evolving. We're adding, we've more than tripled the number of models in, the last 9 months. So again, all of these are available for you within that. And we have, I'll just say this, I can't because it's not quite there. I would also take a look and be looking at SageMaker Canvas. SageMaker Canvas is a no-code solution to do this. And the major people that are using SageMaker Canvas right now are data scientists. It's not that they can't, they have so much on their plates that if they can find shortcuts, and there's some incredible announcements that we're going to be making with Canvas very soon. And how to use Jumpstart, you can choose, again, you choose it, try it out, and you can try it out in the console and run, example. You can just pick your model, run the use case on it. It's literally click a button and go. And then if you were ready to and wanted to, you can deploy the model through SageMaker. And then you can also fine tune. Some of them can be fine tuned. There's a list, and you can automate your ML workflow. Another use case is, so again, we mentioned SageMaker helping on training. In this case with LG, they were able to train the model faster by 59% than without SageMaker. So again, there's a lot of rationale for using our tools. And again, so a lot of these model providers are actually on AWS. And so again, we've got AI21 accelerated their development with SageMaker. And they started out with, I think there was a 7.5 billion parameter model. There's 178 billion parameter model. And yes, you get better, output from that ginormous model, but is it really the most efficient? Is it really the best? Is it optimized? And so what they did is they worked with us and they developed a smaller model of 17 billion parameters. And it made it much more efficient. It was right sized to it. They were able to lower their inference cost, and they were, able to reduce their GPU usage, which saved them money. So again, we've looked at some ways that AWS is unblocking your ability to use your foundation models in GenAI. So what I would say is definitely check out Code Whisperer. Request access to Bedrock. I think that will have general availability. I want to say next month. So I'm hearing next month. I certainly, before reInvent, we'll attempt to those started. I wanted to mention about getting started on a proof of concept. So we do have GenAI incubator programs where essentially we can have, scientists come in and help you to figure out what your business use case is, develop your metrics for it, and then help you get started on a POC. If you have an AWS account team, there's also something called an experience-based accelerator, and they can also help you come in really an incredible dynamic agile methodology. We do it doesn't have to be, but we tend to do 3-day workshops where we have command centers, we have specialists that are brought in, and literally we can unblock your silos and get things happening in record time, which is really a cool and fun thing to do. We make it very party themed. We also have this AI use case explorer. So if you're AI explorer.aws.amazon.com, you can go in and look at the industry, what you're trying to do, what your outcome is, and it will give you examples of how they've been successfully implemented by those that are in your industries. And again, you guys, hopefully I'm pretty much on time. Thank you guys. You're welcome to connect with me on LinkedIn. Happy to get you guys in touch with any AWS resources that might be helpful. So you guys, thank you.
Thank you. Melissa?
All right. So my experience in these events, I've done them around the US and the world, is that you guys want to get to the hands-on portion as quickly as possible. And we want to get you there as well. So Melissa gave us a quick overview of sort of the AWS landscape, what they're seeing from a use case standpoint. I'm going to give you a brief, ideally very brief overview of SingleStore as well. I see some folks in the room that we've been working with and some customers of SingleStore already. So I'm going to take that as a hint that we don't need to go too deep, but I am going to give you just a quick overview of what we're seeing in the marketplace. As you guys probably know, and the reason that we're all here, over the last 10 years, we've seen, or probably 20 years, I would say, we've seen every company become a software company. That's through mobile apps, that's through web apps, that's through any type of application. Every company out there has some sort of digital interface, and what we're really seeing, I think, in the next evolution of generative AI is that all companies are going to become AI companies. And what we're going to tell you about today is sort of how SingleStore is the contextual data platform to allow you to do just that, contextualize data in real time, and make AI-driven decisions. So what is SingleStore? SingleStore is a database to transact, analyze, and contextualize your data in real time. That is a couple key words that means specifically things around our critical capabilities. Transact. What does transact mean on your data? That means the ability to ingest data very fast. We have a super straightforward 5-line interface that is operated through SQL called SingleStore Pipelines that allows you to get data in from anywhere, whether it's AWS S3 or some other object storage that exists out there on the internet. We can get data in to the tune of 12, 15 million records a second is what some of our customers are doing. So that's a very key capability. We actually finished a POC using LangChain at a bank in the UK last week, where we outperformed a vector database on ingesting embedding. Sorry, it's a mouthful. 5,000 times faster than the next vector database that they tried. So pipelines are a key differentiator for SingleStore. We are a distributed SQL database, means you can scale out and you can scale up, similar to any other distributed system. We have a patented table type that is columnar in nature that supports both transactions and analytics, but the ability to do the fact that it's columnar gives you the ability to do very fast analytics. We have customers that are doing single double-digit millisecond level analytics on petabytes of data using SingleStore. And of course, the reason that we're all here and we'll get our hands dirty with in a little bit is contextualization of data, which is the ability to do semantic search, keyword search, anything with vectors, all within the same data platform. So, similar to AWS, we've got a lot of large companies that use SingleStore across the world, anyone from Kroger to GE to Disney to Western Digital. But I think a really cool thing to note about SingleStore is that we also have people that are disrupting their industries, doing real-time analytics, doing AI, doing things like that. Companies like Outreach, a $200 million a year company. Companies like Heap, $100 million a year revenue company. So disruptors in their own industries, as well as Goldman Sachs, Bank of America, and those types of companies. Just a couple of metrics around kind of what I just talked about. We have customers like Akamai that are doing 10 million upserts of a second of data into SingleStore. That's updating records at 10 million a second. We have customers like Comcast that are doing 300,000 records per second streaming off of the set-top boxes that are in people's houses, the people that haven't cut cable yet. And then we have our tier 1 wealth management firm, which actually refers to Goldman Sachs, that is doing 10 millisecond average response time on any query in a wealth management dashboard. That for their sort of richest people in the world that use Goldman Sachs as their bank. So that's at 10,000 concurrent users, 10 milliseconds response time on analytics. So very, very powerful. The theme that you'll hear throughout today over the next couple of minutes is speed and performance. So that speed of ingestion, that speed of getting data in the database, that speed of getting data out of the database, that speed of doing vector matching, that speed of the generative AI applications that you have. So if you imagine going to ChatGPT or going to any sort of AI interface today and asking a question and waiting, even 10 seconds for it to come back, you'll probably go to a different screen and not use it, right? And so that's where the speed of database underneath the AI application becomes critically important.
What
Yeah.
database and what kind of architecture and all that? It's just my mind is
Yeah,
boggling.
I'll get into that. In fact, it's funny you paused me. I jumped into this because I know you guys want to get to the hands-on. I didn't even introduce myself. Like I said, I see some familiar faces who know who I am on the AWS side and the audience. My name is Sarang Tripathi. I lead worldwide solution engineering and delivery at SingleStore. So all of the architecture solutions, as well as all of the post-sales delivery and our education. So I've been with the company for 4 years, deeply technical in this stuff. Gabe from my team is going to cover the hands-on, but that's who I am. So sorry for that. We talked about how SingleStore is a database to transact, analyze, and contextualize data in a single platform. I'm going to talk about what those three things mean very briefly. Transacting with high fidelity, like we talked about, streaming, ingestion, and fast writes to the database. So you want your AI applications to be relevant and sort of relevant to the most recent data that you have. That say if you're building a financial application or you're building a asset management application on IoT devices, asking questions of the application on data from yesterday or a month ago is not as relevant as asking questions about the data now. We have support for very high concurrency on transactions. So think about hundreds of thousands of users asking questions of the database in real time as data is coming in. Think of kind of the ability to do record lookups. So I want to look for an individual record in the database at a sub-second, in a sub-second fashion. From an analytics perspective, we've seen customers get 100x improvement on their queries from other analytical databases. So people using SingleStore versus using something like a Snowflake or a let's pick on another cloud provider or a Google BigQuery or something like that. We find a lot of success sort of there, and that's really because of our patented universal storage. So what that means is I've actually developed and got a patent on a table type that allows you to do transactional workloads, OLTP, traditionally OLTP workloads, as well as OLAP analytical workloads in a single table type. That allows you to do the fast ingestions, fast record lookups, but also large scale columnar analytics in the same table type. This also helps when it comes to use cases where you're moving data around a lot. So a lot of systems, you have a transactional database moves the data through an ETL tool to an analytical database, and you have a latency there, and you have a cost there, and you have a maintenance overhead there as well. So this is just from an analytics perspective, a bit about what we can do. Contextualization, we talked about transact, analyze. This is contextualize. We see 400x improvement off of other database technologies on hybrid search. Now, what do I mean by hybrid search? Hybrid search is the ability, I use an example a lot. Think about who here's robbed a bank before. Okay. So think about if somebody goes and robs a bank tomorrow, there's a video footage of them robbing the bank, right? There's a picture of sort of their face, which is a frame in that video. And then you have a database of, say, 100,000 faces, and you're using a vector database to do matching across those, basically that face in the video, and then the 10,000 different faces that are in my data, or 100,000 different faces in my database. A vector database would do an amazing job at matching to see that John Smith here is John Smith in this picture, right? That's what a vector search will do for you. And it'll tell you, yep, these two pictures are 99% the same. Now, what a hybrid search is, or what a contextual search is gives you the ability to join them and then also say that this is John Smith, these are his 5 friends, this is his current address, this is his last address, this is where he lives today, this is where he went to school, and all of that information. That capability requires support for multi-model types of data. So not just vectors, but also relational data, unstructured data, geospatial data, time series data in a same platform. And so when you think about building these AI applications, that is what becomes very relevant. is how can I get all of the data to help me identify who's robbing the bank and where they live and where I can go get them right now, rather than, yep, these two vectors are the same. Make sense? So, and you'll operate today in the notebooks environment within SingleStore's cloud, wherein you're able to prototype and deploy these types of applications through a Jupyter Notebook type of interface within our cloud platform. So there's a question about sort of the how it works. This is sort of where I'll round off, and this is where it gets a little bit more technical. Our single store pipelines, like I talked about, give you the ability to do fast ingestion of data. Now, how do we ingest data so fast? We actually are immediately hitting memory when we ingest data. So you write your 5-line pipeline statement that says, create pipeline from S3 or create pipeline from Kafka, call my pipeline this, ingest it into this stored procedure or this table. Once you hit go or start, the data starts hitting memory first. Now, the reason we do it that way is that we don't want to be like a data warehouse where you're ingesting into object storage first, and then it takes forever for that data to come up and actually query it. You want the data ingesting into memory, so it's immediately available to the audience that it's served up to. However, you don't want all your data sitting in memory forever because it's going to be too damn expensive, right? So we immediately commit to disk, and that committing to disk is where this universal storage table type lives. And that is where that universal storage table type is the one that we have the patent on, and that you get your 80% compression of various different data types. So your data is not sitting in memory, but it's just ingested into memory, so it can be immediately queryable, and then it's long-term queryable here. We also have a third tier of architecture, which is cloud object storage. So all of this data is backed by the object storage, depending on where it's deployed. So you never lose data. And if you exceed local disk, you can still ingest data here. So you don't necessarily have to scale up your disk, but the data is still available somewhere. Now we do this all in a distributed fashion. So if imagine you're a user using an AI application or some sort of BI app, you're hitting an aggregator node first. The aggregator node is actually just what receives the query and what sends the query down to a leaf node. A leaf node is where the data lives, where the compute lives, where all of the power for the database cluster lives. Typical distributed architecture, nothing crazy going on here. So we'll quickly now get into sort of Gen AI apps, and I wanted to do a time check because I don't want to. Yeah, we're already 45 minutes in. Gabe, I think what we can do is kind of just quickly go through. Let's quickly just talk about the 4 steps of vectorizing data for an application in the next maybe 5-6 minutes.
Yeah.
And then let's jump into the hands-on. And while Gabe's doing that, if anybody on the online or in the room wants to start spinning up their trial, use the bit.ly link that's either in the room on the board, or I imagine we have it somewhere in the chat as well. So you can start spinning that up, and you're ready to actually run the hands-on exercises when we get there. Cool. All you, Gabe.
Thanks.
And maybe you want to introduce yourself too, because
I'll do that at the beginning.
Yeah, that's what you're supposed to do when you start a presentation.
Yeah. Thanks, Sarung, for that. Gabe Cafferty. I'm a solutions engineer at SingleStore here. I've been working a lot with this Gen AI stuff recently, so excited to be here and speak with you all about it. So high level, a generative AI app, I try to simplify it as much as possible. I think about it like a car. And if you have a car, like that's great, but if there's no fuel in the tank, the car is effectively useless to get you from point A to point B. And vector embeddings are the gasoline in the car of a generative AI application. So a vector embedding is nothing too crazy, really. It's an array of numbers, super long numbers, long arrays. It's not extremely human readable, but it is what allows us to power these Gen AI applications. But to Sarung's example earlier, where you have the picture and you're trying to do face matching, you can't just take a picture in the format that it's in now and have a AI app leverage that picture. You need to take an intermediate step of taking that picture breaking it down pixel by pixel, numerically representing that picture, submitting it to a model which does vector embeddings, and that model will give you back the vector embedding, which effectively is the gasoline to your generative AI application car. And once you have that vector embedding, you have the tools that you need to do the things like the hybrid search and the contextualizing of this data. But we really need to take that step of embedding these vectors at scale. So for GenAI apps, this is a few different steps. So let's just take a simple example. We have a paragraph of 100 words, and we want to be able to ask this paragraph of 100 words questions about the contents of that paragraph. So how do we do that? Well, as we just discussed, we need vector embeddings to be able to do that. So step one is we have 100 words in this paragraph. First, we need to tokenize this, and tokenize is just a word that means chunk things up into smaller segments and prepare it to be processed. So let's say there's 100 words, but it's 10 sentences of 10 words. Okay, great. So each one of our tokens is one sentence. So then next we need to create the embeddings. So we're going to take each of these sentences, pass them to an embeddings API, and we'll get back our embedding. Awesome. So now we have our whole paragraph, we have our chunks of each of the different sentences, and now right next to that, we have all of our embeddings for each of those chunks, which as we discussed, are just kind of an array of numbers. Not human readable, but the LLM knows what it means, and that's what gives us the context to run these applications. So then we store these embeddings in a database that is compatible with that type of storage, something like SingleStore, and then we have the ability to search and do all of the great AI applications from there. So let's see. This might be a good one to go over. We're trying to cut out all the fluff here. You know, we want to get right to the brass tacks. Yeah, exactly. So here's how people are doing it today that we've seen in the field here. So typically enterprises are going to have, 10, 20, 30, 50 years of technology infrastructure that has been developed and accumulated over time. So if we look at a typical enterprise architecture, it would look more or less something like this. So we use the financial services application as an example earlier. So let's say we have some end users communicating with our company's application to see their financial services types of data, their balances, their spending over time, whatever it may be. And because we want this to be highly performant, it will communicate directly with a transactional database, which is optimized for things like fast writes, fast single reads, typically the backends of applications, so that there's not high latency when users are interacting with it. And then as Sarang was mentioning earlier, to get this data into a place where we can get historical insights over it and do large-scale querying and analytics, we have some kind of complex middleware in between to pull data from the transactional database, get it into a format that is compatible with our analytical database, which takes time and effort to do. But then once the data is there, we can have our internal users run analytics on top of that data. So how are our customers doing? Not only currently, but also historically, over the last 10 years, how have we been trending for these particular topics? And then here's where it gets tricky. ChatGPT comes out a year ago. Everybody from the top level down at their companies is saying, okay, we have to incorporate this into what we're doing with our businesses today. And companies are just trying to bolt on an additional solution here, where, not only do we have an ETL process now from the transactional to the analytical database, now we also want all of that data to be vectorized and stored in a vector database as well. So imagine we have some middleware here that is creating these vector embeddings that we discussed. Okay, great. So there's going to be some effort. There's going to be some complexity associated with that. But now, when it comes time for the users to actually interact with the GenAI application, you're adding an additional place where these users have to connect to, which is adding, more complexity exponentially from what we've seen in the field so far. So just to contrast that, here is the most common design pattern that we've seen with customers leveraging GenAI applications with SingleStore so far. So we talked about how SingleStore, based on our 3-tiered architecture, we have the ability to serve both transactions and analytics from a single storage engine. Okay, great. But we're also multimodal in the ability to store vectors, as we discussed earlier. So now, instead of having users communicate with the application to go to a transactional database, to go to an analytical database, to go to a vector database, to go back to the internal users, the architecture is much more simplified. We've removed a lot of ETL processes. We've removed a lot of technology overhead, but also a lot of process overhead that internal architecture and engineering teams have to manage, have to update, have to patch, and have to bang their heads against the wall about. So this is typically how we're seeing things progress here. And I'll show you later our internal GenAI app called Squirrel. It's pretty cool. It's in our portal. But, rather than telling you, I think showing would probably be more engaging here. I guess just before we do that, some key product capabilities from SingleStore. We talked about the universal storage piece. We can do transactions, analytics, and contextualizing in one storage engine, really fast with things like pipelines, super deep with things like unlimited storage. We can run anywhere. We're multimodal. We have a bunch of great features, but we came here to actually get a little bit hands-on. So we're at 4:54 right now. We've been going for a while, and we have about another hour in the session. So let's take a quick 5. People can stretch their legs, use the bathroom quickly, and we'll regather right at 5 o'clock sharp to actually go through the demo here.
And let's tell the folks that are online, make sure that they have so for the folks that are online, if you haven't spun up your trial yet, given the link, the bit.ly link that we've posted, please go ahead and do that now while we take 5 minutes in the room. And then we can start with the trial when you guys come back.
Yep, we'll be back at the top of the hour in 5 minutes. All right, we're just a couple minutes past the hour here, so let's go ahead and get started. So if you navigated to the bit.ly link, you should end up at a portal that looks similar to this or exactly like this. So you can log in with an email address or with an SSO provider, and this will walk you through the process of creating an organization for SingleStore, which obviously I have already done here. So this is what the SingleStore portal will look like. I'll zoom in so we can all see here. And this is fun when it's interactive. So if there's like any thoughts or questions throughout, please feel free to shout them out, raise your hand. We're happy to engage. So to start, we can just do a high level overview of what goes on in the portal here. So we have a lot of options here in the left banner. We'll start on the main homepage here, which gives you some guides, releases, and training, blogs and community help, and also allows you to interact with Squirrel, which is our AI co-pilot that we've trained on all of our company data. Things like blog posts, our GitHub repositories, our support tickets. Obviously, all confidential information has been scrubbed, but this has a lot of contextualized information about how customers can leverage SingleStore, how they can optimize their SingleStore workloads. So if we ask it one of the pre-canned sample questions, like what is a SingleStore workspace, it's going to go and pull all of these sources that we have gone through that process that we discussed of creating vector embeddings for every single pieces of this content, whether it's a code block in JavaScript or it's a paragraph on a blog post. And based on all of these different data sources, it's going to provide us its best answer at whatever question that we're asking it. So we can ask it high-level questions as we did here. One of these pre-canned questions about what is a SingleStore DB workspace. And this one's pretty straightforward, where it's just going to go and pretty much read from our documentation, right? And it'll provide some links, which is really cool. But then we can also ask it to like help us program a little bit. So we can ask it like, so I'm building a, we already did financial services. Let's do e-com, an e-com application. Please recommend me some table schemas to start with. We'll find out, right? I'll copy and paste the question again and remove the please. We'll see what kind of attitude we get back. So I'll close.
I'm sorry, that's not that's a question. Just don't give it the option, you know?
If you go to the start page, it should be in the right ribbon on the start page.
Then you gotta close the.
Ask.
So I told it, hey, I'm building this e-com app. Please recommend me some table schemas. And it's, taking its big corpus of data and saying, hey, based on all of the stuff we have, stuff like users, products, orders, order items, etc., would be helpful. Okay, nice. So it makes us a clicks table with the recommended data for that table. Similarly with a products table, so on and so forth. Orders, line items. So based on all the information we have, this is going to be a good starter set for some sort of POC of e-commerce application where we can start pumping some data in here and we'll be good to go. So we can ask it a bunch of different questions like this. I'm going to pat it on the back and said, hey, you did a good job. And it's going to take this piece of feedback into the loop of future responses that, hey, this was good. Keep giving me responses like this. And if it was bad, I would say, nah, not what I'm looking for. And it'll take all of that into consideration when it's providing recommendations going forward. So we are not just discussing AI externally, we're also working to implement it internally at SingleStore. So that's a pretty cool feature for us. So we just we went nuts with Squirrel for a second, but just general overview of the SingleStore DB Cloud portal. So within this paradigm, we have a larger group of resources. So we have a workspace group, which is a big bucket of database resources. And then within that, we have two different paradigms. So I have this workspace group called Atlanta Dev Day. And then within that, we have compute and we have storage. So my compute is going to be in my workspaces. So I have this workspace called Workspace 1, and then databases are going to be our storage. And right now we only have the one system database listed as information schema, but in a couple of minutes here, we're going to pump some other databases in there. If I wanted to create a new workspace group, I'd do so by just clicking create group, you name it, choose your cloud vendor, your region, and some other settings. And then you'd configure your workspace. So configuring workspace 1, and a big part of this is what size workspace you're going to choose. So we've tried to simplify this as much as possible, and we just made it t-shirt sizes. So workspaces are going to be pegged to CPU and RAM, and then they just kind of scale up. So the smallest one is a 2 CPU, 16 gigs of RAM, and that's going to burn the least amount of credits. And then we go all the way up to 3,000 cores and 24 terabytes of RAM in a single environment. And that's one is going to cost you a lot more money. But yeah, that's basically it. We've abstracted the infrastructure away. Again, we can configure some metadata. I'm not going to get too deep into it. And then you'd click create workspace, and in a couple of minutes, you'd have an environment ready, which I've already done for the sake of today. Cool. I'm not going to go through each one of the different develop tabs, but we have some great developer tooling for in-console coding, experimentation, troubleshooting, monitoring, all of these kinds of different functions that you'd want to have when you're pushing and pulling data between applications. We've built that directly into our console. And we're actually going to be taking a look at the notebooks functionality within SingleStore here today. So show of hands, has anybody used Jupyter Notebooks before? Okay, a couple. So some familiarity with Jupyter Notebooks. It's basically a web-hosted development environment that's super easy to get up and running with. So we've taken this concept and we've baked it directly into the product, which is what we'll be looking at here today. So I have two notebooks that I've picked for our walkthroughs here today. One is about movie recommendations, and the other is about semantic search. So both of these are going to be leveraging vector embeddings, AI types of functions on top of SingleStore. So for starters, we are going to go through the movie recommendations one. So if you want to get this environment spun up for yourself, you can click right here on the plus sign by notebooks. It's going to be in Python for us. And then we just released a product update like today. So excuse me, I didn't know where my templates were. So for more templates, we're going to view the gallery page. So now if we come over to the gallery page, we can see that we have a movie recommendations notebook. So we can just click on that one, and it'll load up the notebook for us, which again, I've already done within my own personal notebook. So I'm just going to come over to that one that I've already spun up, and everything's already pre-canned in here. So we'll walk through step by step, talk about what's going on at each step, and take it from there. So we are going to load data from this full movie lens data set. So we're loading in movie data, tags data about those movies, and then ratings of all of the different movies that we have. Then we're going to join this data, create vector embeddings, and then leverage semantic search over these vector embeddings to provide things like movie recommendations, similarities between movies, things of that nature. So I'm going to go ahead and kick off my installation of this sentence transformers library, which is going to take a couple of minutes. And this is all Python running on top of SingleStore. So anything that's executed within one of these notebook cells is actually running in a separate piece of compute behind the scenes. It's not actually on the database, but then when we want to interact with the database, we just use this SQL tag ahead of what's going on, and it automatically knows, hey, I'm in SingleStore, I'm going to communicate with the database that way. But let's take a look at what kind of data we're bringing in here. I'll make this a little bit bigger. So we talked about how we're going to bring in movies, tags, and ratings. So let's take a look at what that data looks like. So first up is ratings. So we're going to get a CSV of ratings data, and the columns that are going to be included with this rating data are the user ID, who gave us this rating, the movie ID, what movie are they talking about, obviously, their rating score, and then a timestamp. With regards to tags, similarly with the user ID and movie ID, but instead of a rating, we're going to get a tag. So a tag could be something like comedy or a region of the world, potentially. Just a bunch of different tags that help uniquely identify that particular movie. And then finally is going to be the movie CSV. So we're going to get the movie ID as a unique identifier, then the title, which is just going to be some plain text, whatever your favorite movie is, and what genre that falls into. So here are some of the genres that we're going to get in our pipelines here. So let's come back over to the portal, and it looks like our pip install of sentence transformers has completed. That's great. So now we're actually going to communicate with the database. So we can run Python and SQL against the database directly in the same place, which is a big value add here. So we're going to create the movie recommenders database right now, which will just take a couple of seconds. And then we'll tell the system, hey, I'm using compute in workspace 1. I think there's a database called movie recommender. I'd like to go ahead and use that for the next exercise that we'll be doing here. So make sure that you call that out and toggle over to the movie recommendation here, so the code knows what data to run against. The next step is going to be getting this data into SingleStore. So we talked about how pipelines are a unique differentiator for getting large quantities of data into the database pretty quickly. So we're going to do this for tags, and then we'll do it for ratings, and then we'll do it for movies. So I'm just going to talk through one example, and then we'll just run the subsequent two, because it'll be a little bit redundant. So we'll create the table in SingleStore, leveraging those fields that we just saw on this different web page. So the tags had a user ID, a movie ID, and an associated tag. Okay, so now that table is there. So now we're going to plug a pipeline into this table. So let's take a look at how we do that in SingleStore. So we'll create a pipeline called tags, and we'll indicate that S3 is the data source for this pipeline. So pipeline is an in-database feature that you can use as a really fast technology for getting data from S3 into SingleStore super quickly.
Just to pause, I did say earlier that pipelines are a 5-line thing. I wasn't lying. Gabe was just doing some additional configuration.
Exactly. I'm getting extra credit here. Yeah. Yeah, good call.
Yeah, that's just sort of showing just various different optimization techniques around pipeline.
Yeah, absolutely. So most of these are optional fields that are not required to configure a pipeline. It could be just, load data as S3 with the file path, and then we could pretty much run it. But we've specified things to help optimize the workload a little bit, such as a batch interval, max partitions per batch. We're not going to get too deep into what any of these details mean. It's very well documented. It's just, trying to make things run a little bit faster. And then we're going to ignore one line. That's pretty interesting because we're pulling in this whole CSV from S3, and we're basically just telling it, hey, we don't need the headers. We already have that defined within the database. So just ignore it, and then we'll be good to go from there. And then once the pipeline is created, it's as easy as start pipelines tags. So we'll go ahead and do that. It runs pretty quickly. And now we'll do the same thing with ratings. I'm not going to go through all of the details again, and the same thing with movies. Okay, great. So now we have created a database. We've told the notebook, I want to communicate with this movie recommender database. We've created 3 tables with 3 associated pipelines, and we've started those pipelines. Okay, so now let's check and see if the data has been loaded yet. So there was 25 million rows in ratings, 62,000 rows of movies, and 1 million rows of tags. And just since we started those pipelines a couple of seconds ago, all of that data has now been loaded into SingleStore. All right. So now we are going to just do some data manipulation to make this a little bit more digestible for our end application. So this is kind of what's going on behind the scenes. At the end, we're just going to go to the super easy and digestible front end. But we're just going to show, hey, what does it take to actually populate this front end in the next couple of steps here? So in this step, we're just concatenating the tags and movies. Now we're going to vectorize the data. So we ran that pip install up front, and we imported a transformer library. That library is what we're going to be using to create the vector embeddings. So because Python is really good at abstracting complexities away from us, we're basically just saying, hey, here's all of our data. It's going to help us chunk it, embed it, and then we're going to store those vector embeddings back into SingleStore. So we can see, hey, there's a bunch of processes running. All is looking good. Okay, and now we can just query the movies with tags to see. Oh. Okay, so now we can see we have the movie IDs and we have the titles with the genres as well as the tags here. So I'm pretty zoomed in, but we have all of the tags. So we can see some movies have no tags, totally fine. But some of the movies like this one, I mean, this is kind of unbelievable. This one has what? Hundreds of tags here. We're not going to read through all of them, but Terminator Salvation. All right. Heavy on the tags for everybody's reference. And I should have limited this so it's not just a huge window. So those are our 62,000 movies concatenated with tags. All right, all good. So now we are going to continue to just do some of this middleware data transformation so that we can serve this backend UI a little bit more simply. So we're just taking the first record of our titles. We can see, hey, here's the unique identifier, here's the movie name, here's the genre, and then a list of tags. So now we have some great information to help create the vector embeddings, which are going to be the context for the application in the final stages. So now we're just going to do another like data transformation step, and then we're going to create the vector embeddings. So this is leveraging that embedding model that we had imported from Python, and we had successfully brought all the data into SingleStore. We chunked it up into the appropriate sizes of like what we wanted to work with, where we have the movie ID with the movie title and the genre and the tags. And now that we've prepped all that data appropriately, we can pass those chunks of data to an embedding library, which is then going to pass us back embeddings, which are just arrays of numbers. And that's going to be how we're able to power our generative AI application here. Embedding is compute heavy. It just really is. And that's why this is going to take a little while. So we're only going to do the first 3,000 records for the sake of time. If we wanted to run this over the entire data set, given this is a super small environment, which is why it's going to take quite a while, it would take
This is the smallest environment that we offer.
Yeah, this is the smallest environment that we offer. So it's going to take a significant amount of time, but
I just want to make one point here, and Gabe, I'm sorry.
Yeah, please.
I'm going to steal your thunder. This is one approach where you bring data into the database and then you create embeddings on that data. The other approach is, and I talked to some of you about this, is generating the embeddings up while you're ingesting the data. So you get the data, you get the record, you generate the embeddings, and then land it in the database. So it really just depends, sort of, your approach is going to depend on how fast, once that data lands, you need to actually run embeddings and run sort of the AI applications and the sort of necessity of recency in your AI app. So it's just an important thing to know that, yes, this could be a process that's running in your database once every 10 minutes, or it can be something that you do, while the data is being ingested.
Yeah, absolutely. And so AWS has a great service called Lambda, and we have customers who are leveraging AWS Lambda to do vector embeddings on the way into the database. So rather than storing data and then using that same data to go to an LLM and create embeddings, which you store back in the database, they've built a, piece of like middleware code, which they run in a serverless fashion, leveraging AWS Lambda to create these vector embeddings in flight. So you don't have to wait on it downstream. They're deciding to take more of the processing and put it upstream. So once stuff hits the database, it's all there, ready to go to power these AI applications that they're trying to power. So it looks like that ran now, and this is interesting. So what is the shape of our embedding? So we limited it to 300 records, and it's saying, okay, great, we have 300 records, but there are 768 columns for each record. So this is telling us we have an array, which is 3000 by 768. So this is telling us, okay, for one vector embedding, it is a combination of 768 different numbers. And it's not a number like 3. It's a number like 0.01927889, whatever, like a huge float number. So this is what the embedding will give us back. So not human readable at all, but super powerful for powering these apps. Yeah, go ahead.
This embedding specific for these 3,000. So if you wanted to expand it to like 5,000 later, you have to rerun the embedding.
Correct.
Or you could have just run around the 5,000 from the beginning.
Yes. Yeah, you could have.
But every time you're creating those embeddings,
It's the full matrix of all of them.
Exactly.
when you're when you're creating embeddings for the new rows, you would need to run them against all of 3,000 again.
Yeah, good question. Cool. So that ran. Just a little tidbit here. Now we can see we created the database. So in our dropdown, we can see movie recommender, and we can come in here and see, okay, we have all of our tables. What are the associated columns in each of those tables with the data types? So pretty intuitive stuff, but helpful if you have a lot of different environments running within one single store organization. So again, we're only processing those 3,000 elements, and we're doing these middleware steps. I don't want to get too into the weeds here because there is the second use case that I want us to get to. So I'm going to click through a couple of these cells. We're importing our native SingleStore DB library, which is something that we have recently developed, and it has a lot of helpful tools in there to help any sort of Python developers for things like data engineering, data science with SingleStore. All right, just going to run a couple more of these before we get to our actual use case, which is going to be leveraging search and semantic search on all of these vector embeddings that we have just spent some time creating. So before we get into that, are there any thoughts or questions on what we've covered so far in this workbook? If not, no big deal. Just getting a pulse check.
One question.
Yeah.
You showed connecting to one data source. Could you do multiple, so heterogeneous data sources?
Really interesting point. Are you referring to? Yeah. So the question is, right now we're connecting to one data source. Could we connect to heterogeneous data sources to do the same kind of workload? So now I'm curious, do you mean for with regards to creating the vector embeddings?
Yeah, you might need to combine information that exists in two different places.
Yes, absolutely. So you might need to combine information that exists in two different places. And you can definitely combine that information from heterogeneous data sources. The requirement would be you leverage leverage the same embedding LLM, because one embedding LLM and another embedding LLM, they are not compatible. So as long as you're leveraging the same downstream technology stack, yeah, you could have one, you could have two, you could have 5 different original sources of this data, but it would require leveraging the same models for embedding as well as the same downstream large language model that can communicate with those embeddings. Yeah, really good question. All right. So in this use case now, we're just going to do a simple text matching, super simple stuff. So we're going to take all of our titles that we've processed, and then we're going to match it against anything that is similar to something like Pocahontas. So if we go ahead and run that, no surprise, the movie Pocahontas comes back with a movie ID of 48. But like, I'm curious, what if we just like did POC, what would come up? Okay, so now we see, hey, it's there's a much larger set that would match that, but this is just simple text matching. Nothing too crazy yet.
There's 2 questions that we have in the chat.
Okay.
One question is the vector embedding set graph database
The question is, are vector embeddings like a graph database for Neo4j? Put simply, no. A graph database is a entity that shows relationships between a bunch of different nodes in a network. Whereas a vector database is a storage engine that is optimized for the storage and processing of these vector embeddings, which, as we discussed, are just arrays, super long arrays of numbers. So a graph database, think relationships between entities, and a vector database, think arrays of really big numbers. That's a good question.
And the second one is, can you please explain the significance of the 768 columns versus 3,000 rows in the vector database?
Yeah, absolutely. So here, let's actually go back and take a look at this. So I'm going to go off script a little bit and save this to make sure I don't lose my place. All right, I'm on step 5. So now if we come over to our movie recommenders, which table do I want? Okay, so we want the movie with tags and vectors. Okay, so if I click into this, we can see all of the different columns in this table. So we have our movie ID, title, genres, and all tags, like plain English, plain integers, nothing crazy. And then we have our vector column, which we're going to store as a blob type. So if we come and we take a look at the sample data, so everything is super easy to read until we get to the vector embedding. It looks like absolute gibberish. But basically, this is just a machine language version of this array of a lot of different numbers. So when we say that there are, what was it, 768 columns, it would be something. Trying to find my place. It would basically be something like this, where we'd have, I'll make this a little bigger. I don't know if that'll help. So like we'd have an array of numbers, and I'm simplifying the numbers. They would be super long float numbers, but it'd be something like 1, 2, 3, 4, ... 7, 6, 8. And this is what a vector embedding would look like. But instead of simple integers like this, it's super long float numbers with many, many decimals per place. And that's, in simple terms, what a vector embedding is. It's just an array of numbers. But in this example, we are seeing the machine readable version, not the human readable version of that array of numbers. Yeah, good question. All right. So we ran that step.
You put something in, no matter what, you're gonna get 768 different values out?
That's a really good question. So the question is it like a hash where if you put the same input in, is the result set going to be identical? So with regards to embeddings, yes, it's like a hash, but then it gets interesting when you get to the LLM layer, when you're giving those embeddings to a large language model. This is where the whole concept of hallucinations come up, right? Where you can ask something you can ask a model the same question twice in a row, and the answers may be different. It's the same kind of idea where if you'd pass one of these models a vector embedding, it is most likely the answer will be similar, but it could also be something different, right? And this comes into deeper level concepts than we're discussing here today, but this is like model training, model tuning types of conversations. But yeah, with regards to the embedding, it's like it's a hash. That's a good way to think about it.
So no matter what, whether it has 8 tags or 80 tags, it's still gonna have 768 data points that it's measured against, right? Will that 768 grow or shrink?
That is, so for this sample set, because it's the same data schema that we're passing to the embedding model, it's always going to be the 768. But if we chose a different table to create embeddings for, it could be 500, it could be 1,000, it could be whatever.
But so it's the data, it's the schema that drives that.
Correct. It's the, every element that you could think of with the schema, like how many columns are there, what data types are there, how much data is there per field, like anything you could think of. I'm just going to click through some of these. I really want to get to the next use case. So now we're just going to build some logic where we're going to be leveraging our dot product functionality. So dot product is a way to compare two vectors and see how similar they are. Pretty straightforward linear algebra stuff, but we don't need to get into the logistics of it here today. So now we actually can interact with this thing. So we went through a bunch of phases to see how it was built. So now we can interact with it. So let's say I want to see a horror movie. So if we tell the model that we want to see a horror movie, and then we run this next code cell, which is basically just running a query against that fact, leveraging these embeddings, we get back a bunch of horror movies. Okay, so we have a list of 10 with their thrill score. So it's saying, hey, Gabe said, I want to watch a horror movie, and it associated horror with thrill and said, okay, he wants to watch a horror movie, so we're going to assume high thrill score is a good thing for this use case. And then we just limit it 10, so it's going to give me back the top 10 use cases for that. So like, I don't know, what's another genre or another type of movie anyone has in mind? Sci-fi. I don't know if there's a space. Let's just see how it interacts with this. Okay, there we go. So some sci-fi movies. So we got Dark Side of the Moon, Lords of the Deep. And this is interesting. So notice how we are getting a thrill score for the first one and the second one, but the third one, it's giving us a sci-fi score. So even though some of these movies can fall into multiple categories, it's just, taking the context as to which tags all of these movies have. And based on those tags, it's making similarity matches to all the other movies that are in the data set. So sci-fi is another one. We'll do one more. I've seen someone do an example of French comedy. So let's do French comedy. And we do have some French comedies in the data set, and it's ranking them based on comedy score. So this one's comedy score. This one has no genres listed, so it's just based on an overall score. But because we asked for a French comedy, it's going to give us something that's French. So this is all, it's imperfect, but it's just giving us recommendations based on the corpus of data and what we are explicitly asking for. So that wraps up use case 1. So any thoughts or questions about our movie recommender app? Oh, and then this is plugging it into the front end here. And this one's pretty straightforward. So we want to give it 3 movies, and then it's going to make recommendations based on the 3 movies that we ask about. So I like Home Alone. Let's just say the original Home Alone. What's another movie? I don't know. Star Wars. Any preference? All right, let's do the Clone Wars. Okay, and then a third one. Dude, where's my car? Let's see. Dude, where's my car? 2000. Okay, so we have a very diverse set of movie preferences here. So, last 3 nights we've watched Home Alone, Star Wars, The Clone Wars, and Dudes, Where's My Car? Okay, AI application, what movie am I watching tonight? Close. All right, so we had a pretty diverse input of movies. So the match scores aren't great. We're only getting 40%, but it's saying we're trying to build a reference point based on the inputs that you're giving us. So we got things like Road Trip, The Kid, Fanboy, so on and so forth. So that wraps up use case 1 here. And I want to get through use case 2 because I think that one's pretty cool. But before we do that, we can pause for 60 seconds, decompress for a minute, and if there's any questions that come up, now's a good time for them.
There's one in the chat. Someone asking, can you please try, I want to see a horror comedy.
A horror comedy movie. So we got Neighbors, The Booth, The Mummy Theme Park. So some of them are based on comedy score, some are thriller. Okay. So we're getting a mixed bag with horror comedy, which I think is acceptable. Yeah, that's a funny one.
And another question just came up. The recommendation is based on dot production similarity.
Correct. The recommendation is based on a dot product similarity between vectorized information for all of the movies. So the title, the year it came out, the rating score, the genre, all of the tags associated with it. It's doing dot products in between all of those embeddings. That's a good question.
So I ran the tutorial, I ran the same query and I got different results than you did, but every time I run it, I get the same result. So when does it recalculate the difference?
That's interesting. So in this step 6, so what is your prompt here? Horror comedy, and you got different output. That's interesting.
The embedding.
Yeah, so here, let me run it again. So I got Neighbors, The Booth, Mummy Theme Park. Yeah, so I'm getting consistent ones each time as well. So this is interesting. This could be coming up from a few different places. For starters, when we truncated to just 3,000 records, I'm not sure of the ordering of the records at that point, but if you and I have different subsets of those 3,000 records, then the reference to this information is going to be different, and that could lead to the difference in output for starters. But yeah, that is interesting. And to your point, it could be based on the vector embeddings not being identical for multiple runs of the same information, which I thought they would have been, but I can't read that non-human readable code, right? So I didn't know if they were the same or different. Yeah, go ahead.
So with the model in this case, both the tags are technically different, but kind of the same thing. So for example, scary and horror. There's different tokens of words, but technically they're kind of the same thing.
Right.
With the model in this case, you have to handle that like a social code. So for example, scary comedy was kind of the same as horror comedy.
Right. Yeah, so that's a good question. So if there is any association between the word scary and the word horror. At the end of the day, the embedding model and the LLM are looking at these all as just like tokens or embeddings, right? So to us, it is this word scary or this word horror, but downstream, when this is being tokenized and created as an embedding, the model is only going to notice the similarities or differences based on the dot product that we're producing. So one would assume that the similarity of scary and horror would be, let's call it 0.95, whereas the similarity between comedy and horror result set might be 0.4 or something like that.
Is there a way to extract, or I guess just kind of encode in a human readable form that vector? So if I wanted to literally go find each, 2 different movies in the database, go get that non-human readable, whatever, put it into some TF8 or whatever, and then get a bunch of floats or whatever, like a vector of floats.
Yeah.
Is there a way to do that?
Yeah. So the question is there a way to get a human readable vector embedding? Which is a really good question. And I'm going to go off script again and see what happens if I query that table. So I okay, I'm getting so, and so we got to do, what is it, the oh, select all from so not exactly human readable. That's interesting. I don't know if there are ways to kind of decode the embedding to make it more human readable, or if this is kind of as clean as it gets. Yeah, all right. So the next example, we have about 15 minutes left. I want us to get out a few minutes early. It's been a long day for everybody. So the next one is going to be another pre-canned notebook. So load it up if you'd like to, or just, listen along and treat it as a demo. But this one is going to be if we come over to the gallery page, semantic search with OpenAI QA. And we're asking questions about the Olympics, so I called it semantic search for the Olympics. All right, so same deal as before. We're going to install some Python libraries to help us do this work. We're then going to import 2 different models. One is for the embeddings, which are gonna, we talked about this. We're gonna pass it data. It's gonna give us back embeddings, and then we're gonna use those embeddings to give to our GPT model, which we will do so using GPT 3.5 Turbo. I plopped in my OpenAPI key here. So if you have one, you can do the same. And now we're going to just test the connection. I don't even know what this cell does. Oh, is this one? Okay. So basically now we're at a point where we've plugged in our OpenAPI key and we have the ability to talk to, this is basically the API version of ChatGPT. So we asked the API version of ChatGPT, who won the gold medal curling Olympics for 2022? And it's saying, hey, sorry, I'm just an AI and I don't have that kind of information because my last training information was early 2022 and the Olympics happened after I have been trained. So now let's get some data, prepare that data, and ask it the same question later to see if it can get that result back to us. So again, Python's great for all of this data and AI stuff. So we're going to install some packages here. I'm sure a lot of you, if you work much with Python, have seen some of these before. They're, yeah, pretty common data manipulation libraries. Hopefully this doesn't take too long to run. I'm going to be a little bit more brief with this one, given, we're all at the edge of our seats at the end of the day. So we're going to go get a CSV from a public endpoint, and we're going to bring that CSV into this environment. So this is just kind of downloading that CSV, and we're going to process it a little bit into a data frame, which is just, this is all happening in Python. So this hasn't been written to SingleStore yet. We're just processing it as a data frame. So this is sitting in memory in Python. And here is the information that we're getting. So we get some text about what's going on, as well as an embedding, which here is a nice readable embedding where it's just that array of numbers. So you can see like each one of these numbers gets really long. Cool. So we can see, hey, we have 2 columns in this table, text and embeddings. So now we'll set up our database. So we're going to call this one Winter Wikipedia, which we're running now. So I guess that was our data source, was a Wikipedia data source. So let's toggle over to the database we just created, so SingleStore knows what to communicate with. So now we'll create a table to store this information. We'll do ID, text as plain English, and then the embedding, which we'll store as a blob type. Again, we're going to import the SingleStore library. I believe this one might take a couple. Oh, didn't take too long to run at all. We're just going to run some code blocks here. We're going to see that we have, hey, here's the information that we loaded in from this CSV. We've chunked it and tokenized it and have created embeddings off of it. And now we're going to ask that same question. After we ran through all of these steps, prepared the data, created embeddings, we asked it 3 minutes ago, who won the gold medal for curling in the Olympics of 2022, and it didn't know. But now when we ask it, it knows that the gold medal winner for the 2022 Winter Olympics in curling was Sweden. So we brought in CSV data, prepped it, embedded it, gave it to a model, and now that model can use that information that we inputted as context to help our end users, which is us in this notebook in this case, answer questions about that data.
So are you passing the full data set in the API prompt to ChatGPT, or are they querying the database themselves?
That's a good question. So the question is, are we what happens? Do we push information to the embeddings API, or does the embeddings API like pull and come get information from us? So the flow of the information here is we brought the CSV data into SingleStore and prepared it in a way that was more consumable. And once it was, we pushed that data out through, we used 2 different libraries here. So to create the embeddings, once the data from the CSV was already in the environment, we pushed it to the embedding model. And then the embedding model, by default, it takes these input tokens and it gives you back an embedding for each one of the tokens or for each one of the chunks that you passed it. So we got those chunks back, or those embeddings back, stored them, and then we took those embeddings and passed them to GPT 3.5 Turbo, which is the GPT model in this use case. And then from there, that's where we were able to have that chat interface where, it had the context as to the information in that CSV.
So the API request basically has the prompt, and then also here's other information you can reference.
Exactly. So when we're communicating with the LLM, we can pass it plain English, and we can also pass it the vectorized embeddings to use as context in the response that it's going to give us.
Is there a size limit to how much you can?
That is a really good question. Is there a size limit to how much you can communicate back and forth? Yes, there is, and it's continually increasing with all of these new generations of models. You know, at some point we thought like 1 million tokens was a bunch, and now the amount of tokens that you can pass to a model as context is up into the billions. And it'll, you know, kind of keep continuing to grow. And then which models you're leveraging plays a big factor as well, because like some models are open source and like free to use. And those are kind of two different things. So the ones that are free to use are going to have capacity limits by default, because they don't want you to drain all the resources. And then the ones that are open source, you can kind of fine tune a little bit more. This is developing very quickly, and the number of tokens that you can pass to these models is going up like every month with each new version. Yeah, really good questions. That is all I had today to present. So really appreciate everybody tuning in here. We will follow up with all of the content that happened, you know, the slide deck, and then everything that we did was just within the SingleStore portal here. So everybody who joined here virtually, thank you for joining. Hope you all have a great day, and yeah, be well. Thanks. So I'm going to leave this, and then now the Zoom part is over. So if there's any like additional thoughts or questions.
Wait. We need to wrap it up with the raffle first.
Oh,
and announce the winner.
I left.
It's fine. I'll do it. But yeah, we still have a good number of people still on the Zoom. So I'll just wrap it up quickly. Just want to say thank you to everyone that joined. Thanks to Melissa, Sarang, and Gabe for a great engaging session. Thanks for everyone in here coming out to the AWS office. Thanks to AWS for hosting us. And for the raffle, want to announce the lucky winner of the Apple AirPods. So our winner is Randall de Costa. He's the lead developer at QGistics. I believe he's based out of Atlanta, so I don't know if he's in the room here with us or not. If you are, come up to me and let me know. If not, I'll post my email address in the chat so we can get you your prize. And just a reminder, we have a happy hour happening at 6 at the Industry Tavern. That's down the street from here. So if you all still have time, feel free to join us. And everyone at home, if you live in Atlanta and you're close by, feel free to stop by. And yeah, with that, we can wrap it up. And thank you, everyone.
All right.
All good.
Thank you. That was very interesting.
Thank you for coming out. You know, the space is developing quickly. We are, I feel like privileged to be able to work closely with it, and you know, just trying to learn as much